This webcast is looking at Worksheet 2C, where we're talking about velocity and speed. So in this worksheet, in the first problem, we have three position versus time graphs, and they're showing us a skater's motion during three trials. Okay, so we're going to just take them one at a time to start with. So in trial A, I see a position versus time graph which has a linear trend. It shows the skater beginning at a position of 10 meters, moving in a positive direction at a constant speed. I know it's a constant speed because speed is given as the magnitude of the slope. Since it's linear, the slope is the same for the whole trip. Okay, over here in this yellow sticky note, we're looking at the difference between the displacement, the distance, the velocity, and the speed for this trial. Well, the displacement is the final position minus initial position. And I can see right here that this is the final position of the skater at position 30. The initial position of the skater was at 10 meters at time 0, so 10 meters. So 30 minus 10 gives me the total displacement, which was 20 meters. It's a positive 20. That means the skater moved 20 meters in the positive direction. Now I could find the distance here. There was only one part to this trip because there was never any change in direction, and so the distance is just the absolute value of the displacement, which was already positive. So the distance is also 20 meters in this case. When an object only moves in the positive direction and there are no changes in direction, then displacement and distance will be the same. And since displacement and distance are the same, it's going to be the case here that velocity and speed for this trial will also be the same. The velocity is the displacement divided by the elapsed time, so the skater moved 20 meters in 10 seconds, and so the velocity is 2 meters per second. If I wanted to write an equation of motion to describe this skater's motion in trial A, it would be, the dependent variable is x, which means position. So the skater's position equals the slope, which is 20 meters per second, times the elapsed time, plus 10 meters, which was the y-intercept, or the starting position. Okay, let's look at trial 2. In the second trial, the skater started at a different position. It looks like perhaps 4 meters was the initial position, and they move in the positive direction at a constant speed, and they end up at a final position of 34 meters. So the displacement was 34 minus 4 was 30 meters. They were displaced a little bit more in trial B than in trial A. Again, since this skater always moved in the positive direction and there were no changes in direction, in this case, displacement and distance are the same. The velocity in this trial is larger than the velocity for trial A. The displacement divided by the elapsed time is 30 meters divided by the 10 seconds, so the velocity here was 3 meters per second. The equation of motion is the x equals the slope, which is 30 meters per second, times the elapsed time, plus 4 meters. Okay, and then let's look at the third trial. This one looks different. We have a position versus time graph that is not one line. We can see that there are really 3 parts to this trip. There is the, let's see if I can get a different color pen. There's the first part where the skater was moving in the positive direction. And then we have a middle part where the skater paused for a couple of seconds. And then we have the third part where the skater moved in the negative direction. Okay, so to find displacement for this trial, again, we only care about the initial and final positions. So the skater started at a position of 0 and ended up at a position of 12 meters. So the total displacement during this whole trip was 12 meters in the positive direction. The distance, though, is going to be the sum of the absolute values of the displacements in each part of the trip. Like we could kind of take like A, B, and C. So for part A of the trip, the displacement was 16 minus 0, because as the skater moved in the positive direction, they started at 0 meters and ended up at 16 meters for that first part of the trip. For the second part of the trip, what I've labeled B, they stayed at the same position, so their displacement was 0. And for the third part of the trip, they moved in the negative direction, so their final minus initial positions were 12 minus 16. They went 4 meters in the negative direction, but for the purpose of distance, we're taking the absolute value. So that's really 4 meters. When we add those three things together, 20 meters is the total distance traveled by the skater in trial C. So when the object experiences changes in direction, then the displacement and distance are not equal. And also that means then that velocity and speed will not be equal, because velocity, which is the vector term, remember it gives us information about the direction that the skater is moving. Velocity is the displacement divided by elapsed time. So in this case, that was 12 divided by 10. That average velocity was 1.2 meters per second. But the average speed was the distance divided by the elapsed time, which was 20 meters divided by the 10 seconds. So the speed was 2 meters per second, while the velocity was only 1.2 meters per second. Did the skater start at the same position for each trial? And how would we know? Well, no, they didn't, because in order to know the starting position, we look at the y-intercepts, and those were different. In trial C, they started at position 0. In trial B, they started at position 4. And in trial A, they started at position 10. So in each trial, they had a different starting position. I'm sorry. Here we go. Let's look at the next question. How can you use the graph to determine how far the skater was from the origin at time 6 seconds? So we would take our finger and go up at the 6-second point to find what point on the graph it has an x coordinate of 6 seconds, and then we would take our finger to the left to see what would be the y coordinate for the graph at that time. So I'm showing an example for trial A, and at trial A, the skater is at a position of 22 meters at time 6 seconds. Was the skater's speed constant in all three trials? So it wasn't constant. What we would look at to understand that is the magnitude of the slope is giving us the speed. And so in trial A and trial B, both of these position versus time graphs were linear, which do say that the skater was moving at a constant speed, but it wasn't the same speed, right? The slope in trial B was steeper and so the skater was moving faster in trial B than in trial A. But in trial C, the slope changes. There are actually 3 distinct parts to her trip in trial C. So she was not moving at the same velocity the entire time. First, she was moving at a fairly fast velocity in the positive direction. Then she paused for a couple of seconds, so she wasn't moving at all. Her speed was 0. And then she moved at a slower speed in the negative direction. So her speed did change in trial C, was not always constant.